Hey Alice.
Hey Sarah.
Guess what? I finally watched two movies I longed to see.
Oh really? What movies were those?
The Titanic and Air Force One.
What? Those movies are so old, circa 1997, and you just finally watched them?
You know what intrigued me most about both movies? Is how while ships and planes are so heavy they can still float and fly, especially when both are made out of steel and other materials. How is that even possible?
It's pretty simple if you ask me.
I did.
Just think of air and water as fluids. Boats, ships, or any watercraft that are made up of steel and other materials can float, according to the Archimedes principle, when it has displaced a volume of water that equals the total weight of the boat, whether it's fully or partially immersed. What's even more spectacular about this phenomenon is that the interior of the ship is filled with air that contributes to the total volume. The total air volume of the ship's interior causes the ship's density and downward gravitational force to become less than the upward or buoyant force and density of water, permitting the boat to float.
Okay, then so why do planes fly? I mean, I know the interior of the plane wouldn't be filled with water causing the plane to be buoyant and fly, could it?
TSK, TSK, TSK. You didn't let me finish. A plane has a similar process, but follows a different principle, and no, the plane's interior would not be filled with water. A plane flies because it generates a force called lift. Lift pushes an airplane upward, while a downward gravitational force is pulling it towards the earth, and a drag force is produced by air resistance, slowing the plane down. Without wings and its unique shape, on an airplane, there would be no lift. We can apply the Bernoulli's principle in this situation that says, as speed increases, pressure decreases. As the wings travel through the air, the wing's unique shape causes air to travel faster above the wing than underneath it. The faster speed creates a lower pressure above the wing, while the slower speed underneath creates a higher pressure. This difference in pressure produces the lift, allowing the plane to fly. Another principle, Newton's third law, also correlates to flight. When the wings are traveling through air, they push air downwards, and while the wings are pushing air downwards, the air is also pushing the wings upwards.
Okay, so let me get this straight. A boat floats because the fluid in which it is floating balances the downward pull of gravity and pushes it up, allowing the monstrosity of a ship to be buoyant in liquid. Then if the density of the ship were greater than the density of the fluid, it would sink. Oh, so that means when the Titanic hit the glacier, it had to have released the air that was contained in the interior of the ship while water was entering it. This then would have had to release the total volume in the empty space, causing the ship's total weight to become denser than that of the water, causing it to sink. And a plane's flight is sort of like floating in water but in air, caused by the difference in speed and pressure of air over and under the wings. So then, if the plane gains more speed, the higher the lift will be, but if speed is reduced, the lift wouldn't be as great. So, in the case of Air Force One, when the plane ran out of gas and the engines failed, the plane lost the momentum to fly, thus slowing down speed and losing the flow of air around the wings, eventually crashing the plane into the ocean. Aha, I get it. Physics that explains it.
That's right, Sarah. You've got it. It's all based on physics. Ha, ha, ha.